If you look at the wake behind a duck, or a kayak, or a ship, you might notice two unusual things. First, the wake isn't simple like the perfectly straight shock wake of a supersonic projectile is. It's a fascinating feathery, ripply pattern. And second, that feathery pattern looks the same. Same angle, same repeating pattern of ripples along the edge, same reverse arcs in the middle. It looks the same regardless of whether it's made by a duck, a kayak, or a ship, even though they're all moving at different speeds and the waves are very different sizes. In this video, we're going to explain exactly where this shape comes from and why it looks the way that it does. Ultimately, it comes down to the surprising physics of water waves. While there's a single speed of light waves and a single speed of sound waves, there is no single speed of water waves. In water, longer waves travel faster, while shorter waves travel slower, at least for waves that are bigger than a few centimeters. This phenomenon where different wavelength waves travel at different speeds is known as dispersion, because waves of different speeds disperse from each other, and it makes water waves both interesting and complicated. Like a boat wake. To explain the shape of a boat wake, we'll start by looking at water waves of just a single wavelength and speed. A boat traveling across this simpler water creates a series of circular waves. If the water waves are faster than the boat waves encircle it, but you don't get a wake. If the waves are slower than the boat outruns them, and the circles all add together to create a V-shaped wake. And if the waves are even slower, the boat will outrun them even more, and they'll add together to a narrower V-shape. Slower waves make narrower wakes. Faster waves make wider wakes. But we need to remember that water waves are waves. That is, they repeat themselves. So every circular wave is really the first of a series of circular waves. This means that instead of creating just one V-shaped wake, a moving boat creates a train of V-shaped wakes that are each exactly one wavelength apart. The reason a real boat doesn't make straight V-shaped wakes is that a real boat makes waves of many different wavelengths. And because of dispersion, different wavelengths travel at different speeds. The longer ones travel faster, and shorter ones travel slower. Faster waves create wider wakes, and because faster waves also have longer wavelengths, that means wider wakes are further apart. Similarly, slower waves create narrower wakes, and because slower waves also have shorter wavelengths, narrower wakes are closer together. The specifics are determined by water's dispersion relation. When you add together narrow, closely spaced wakes with wider, more widely spaced wakes, with even wider, even more widely separated wakes, and so on, voila, the shape of a boat wake. Look at the beautiful repeating feathery ripples out on the edge, and the wider repeating arcs inside the wake itself. I find it so cool that you can recreate the shape of a wake just from these lines. If you replace the sharp lines with smoother waves at the appropriate angles and spacings, you get an even more convincing boat wake. And we can do the same again in 3D to get a really realistic looking boat wake. So in summary, boat wakes have the shape they do because water waves travel at different speeds. Slower water waves create narrow, closely spaced V-shaped wakes, and faster water waves create wider V-shaped wakes that are farther apart. When you add all these different V-shaped patterns together, at the correct angles and spacings determined by water's dispersion relation, you end up with the unique shape of a water wake. Okay, there are some caveats to the science in this video, and you can find out about them in the extended version over on Nebula, the Streamy Award-nominated independent streaming service that's the co-sponsor of this video. Nebula was created by and for a collection of educational video creators including Real Engineering, Mike Boyd, Up and Adam, Jordan Herod, and me. And Nebula has partnered with CuriosityStream, which offers thousands of documentaries and nonfiction titles, to give you access to both in one go. I recommend Magic Numbers, Hannah Fry's fun series about mathematics, how math has influenced science, how science has influenced math, the question of whether math is invented or discovered, and more. Sign up for CuriosityStream using the link in the description, and you'll also get access to Nebula, including the extended version of this video as well as an ad-free viewing experience across the site. Oh yeah, and you'll also get 26% off an annual subscription to CuriosityStream.